Hello everyone, this is Pranay. Today we will be seeing our Unix experiment number 8. This experiment is related to the concept of process and process creation. So in process creation, there will be a parent process, and for that parent process there could be a child process, or we can create a child process, and we can create multiple childs for a single parent, or we could just create one parent and we'll create a child for that parent, and we can create a child for that particular child, and like continue like a hierarchy we can do that. So there are different ways we can create these childs. So for creating a child there is a system called name fork, okay, that is used to create a child. And when this fork is executed, that fork will return a value, a kind of a process ID kind of thing. If that value is 0, that represents the child, and all the other else part represents the parent. Okay, so if you want to just create a child for a particular process, you just create a fork, and if the particular for example, let's say PID, if PID is equal to 4, and that PID equal to is 0, and inside that it's a child process. And if you want to create another child process, again in the else part you create fork and you implement that, and again you can just create two childs. Otherwise you can just put else if, and you can create multiple childs. So let us show the concept of process and its process creation and child creations through some programs. So let me just open one of the program. So here, sorry, the net is a little slow. Just hold for a minute. Sorry for that small technical glitch. So this is our first program. In this program we'll try to create uh, a single child for a parent. Okay, so this is a C++ program, so has to include the required header files, and we'll take a process ID, okay, that which is of PID underscore T type. Okay, in this program we'll take seconds, and the child process will convert these seconds into minutes and hours. Okay, this is a basic program. So to create a child, as I've told you, we use fork first of all. The fork will return some value. So for example, if it returns 0, that means it's a child process. Okay, and this will represent the child, and process ID, then child process ID, get PID. Get PID is the function which is used to get the process ID of that child. And if you want the parent's process ID, we use get PPID. Okay, and I'm here using sleep function in the parent ID because I want to just what do you call it? I just want to show the child process first, then the parent. I don't want because these two can simultaneously execute themselves, or the parent process can execute first, or the child process could execute first. To avoid that situation, I'm just using the sleep function, and let us see how this works out. Okay. So let me compile this program, G++, q1.cpp. Okay. Okay, the program is compiled. Let me just run this. Okay, ./a.out. Okay, I guess the Carnier service will be slow. We have to wait for it. Okay, now it's asking for us to enter the seconds. Just we'll enter 3600 seconds. As you can see, the first child process will be executed, child process with the process ID of 6437. minutes are 60 minutes and the hour is 1 hour, and the parent process ID is 24253. Okay, so this was our first example for the concept of process creation, in which there was one parent and one child. Now let us check the second program. So vi q2.cpp. So in this program we'll have some functions. First, to check whether we'll enter a string. In the first in this first child process, we will try to reverse the string, and in the second child of the parent or the second child of process C, as we put it here, we'll check whether that string is a palindrome or not. Okay, this is a function. So how it is done? So if PID is equal to 0, this you all know, fork will return some value. If it is 0, it is a child process, first child process. Else I'll sleep, I'll print the parent process ID. Now in this I want to create two childs of the parent, right? So to create two childs of the parent, in the else part I'll again call the fork function. Okay, this will return some value, and if this PID is equal to 0, it will create another child. So for example, there is A, so there will B and C will be child of A, and this is created in else part. Okay, so what the first program will do is child B will reverse the string, and child C will or the process C will check whether it is a palindrome or not, and the business logic is there in this program. Okay, so that okay, let us run the program. G++ q2.cpp enter dot slash a.out. Enter the character one by one. So example, I'm entering it is going into the buffer. So A, enter B, A. To end this entering of that, I'll use E. Now the values have been entered. The reverse of the string is A, B, B, A. Let's see whether it is the child process B ran first, and afterwards process C ran. This is the parent process ID. A is 24253, child B process ID is 7121, and child C is 7130. Okay, and yes, it is a palindrome. So our program number 2 was successfully completed. Now let us see the third program, which is a little bit complicated, but it's just a hierarchy of many childs. That's it. There's nothing else, and there's some logic because we needed some functions in it, right? So we'll just open. I'll open that file q3.cpp. Okay, in this there are like 5 processes are there. Okay, no, as you can see, in this there is a power function, there is factorial function. Let us see how many childs are there, and also the how many hierarchy of processes are there. Sorry, there is network is kind of slow right now. Okay, sorry for that small technical glitch. Now again, so we were at the third program. So in this program, we start from the top. So get a number, and we'll check the factorial of that number, the Fibonacci series. Okay, then whether that number is an Armstrong number or not. and thus whether it is a prime number or not. Okay, there are multiple processes to check that. Let us see the hierarchy of these processes. So first a fork will be called, that is the first child. If PID of equal to 0, then process B will be executed and its process ID will also be printed. That is factorial of a given number. Okay, now inside this I'm trying to create another. So B will have his own child. So PID2 is the another child process. Okay, that is child process D. So B will have a child as D, and that will show the what do you call the Fibonacci series for that particular number that we have entered. Okay, now so A has one child B, B has one child D. Now in the else part there is one A will have one more child. Okay, and that child will print, that child will check whether the number is an Armstrong number or not. Okay, and that particular process C will have its own child named as process E, and that process E will check whether what do you call this whether the number is a prime number or not. Okay, now that same B, the second child of A will also have one more child. Okay, that is 4k. Okay, and we'll try to find the reverse of that number. Okay, this is the hierarchy of the what do you call our processes. Let us execute this program. So G++ q3.cpp, it's compiled. a./a. Okay, now let me enter some number. Let's say I'll enter 13. Okay, so first process B will run. Factorial of that number is 1977. Okay, now afterwards process D will run the Fibonacci series till 13, 1 2 3 4 5 to 13. Then process C, it's saying it's not an Armstrong number. And process E, it's saying it's a prime number. And process F, the reverse of the number is 31. So as you can see, all the processes ran one by one. I've used sleep function in this just to avoid random execution of processes. Okay. So this was our experiment number 8, which shows the concept of process and process creation, child, and the use of fork system call to create these child processes, etc., etc., and how you can create the hierarchy of these child processes. Hope you have learned something from it. Hope to see you again. Bye bye. Have a nice day.